use Desmos to check ourselves. We'll definitely do 1 and 2 and 3. We'll end up really doing them all. Some to check, some to just. So with the first one, you can do this one of two ways. One, distribute the negative to everything. I think that would be the easier of the two because you don't really have like terms in both sets of parentheses. If you didn't do it this way, that's okay. And then rewrite everything. So 7a squared plus 6a minus 2 plus 4a cubed minus 7a squared minus 5. And then you're just combining like terms and rewriting so that the highest exponent goes first. So 4a to the third doesn't have a like term, so that will go first. 7a squared cancels with negative 7a squared, so nothing there. 6a is by itself, and negative 2 minus 5 would be combinable. So 4a to the third plus 6a minus 7 would be that final answer. Because you can check yourself on simplifying and combining like term problems, we're going to do that one in Desmos. So you would put in the original as is. I have this up here already. So I typed in the whole thing. I'm going to add a slider, change the value to something, and then put in our original answer, our answer, and see if the numbers match, and they do, so we know we did that right. Was number 2 a function? Yes, it should have been. It passes the vertical line test. You can draw a vertical line anywhere, and it doesn't touch it more than one place, so that was a function. 3 was line of best fit, so you should have been either remembering the steps on how to do it on your calculator or trying to do it on Desmos. So you would have to first add in a table, put in all of your values of that table. After you have those values, if you want to see these points, you can hit the magnifying glass, and it'll take you to where those points are. Then you need your regression equation, so you're going to type in an equation that looks similar to your line of best fit, your linear equation, y equals mx plus b, but not at the same time, because you need y1 from the table, x1 from the table, and a squiggly line instead of equals. When you type that in, it's going to give you m and b. So the equation you're looking for would be this one. Y equals negative 0.85 x plus 15.9. That would be your answer to number 3. Questions on these so far? Or I'm going to show you how you can check yourself. If you type in the original but with capital X's or change the variable to something that's not X or Y, it'll ask you to add a slider, distribute, combine your like terms, and you should have gotten 25x plus 10. So if you got that, good job. If you didn't get that, go back and see where you made a mistake. And then for number 5, you were given your slope and your y-intercept and could use those to graph. I'm going to get rid of this stuff. You could also graph this into Desmos and look at the x and y-intercept, graph it like that. But it should have been a positive line starting at -1. Questions on either of those? So everyone should have these notes in front of them. Today we're going to talk about more factoring methods, different than what we talked about last class. DCF and different squares. You won't need your laptop for this, so you can close it, those of you with it open. So for this type of factoring, you're going to see a trinomial, so 3 terms, where whatever the value in front will be 1. So we can call these basic trinomials or trinomials where a equals 1, either or, interchangeable. There's really only one way to do these. They're like puzzles. If you don't like puzzles, I'm sorry. To get one specific set of answers. But we have to figure out how to do that. So the number that's given, we're going to multiply to get C, whatever that is. Whatever numbers we find that multiply to be C, those same numbers have to add up to be B. And we have to see which ones work. And those will be our factors, our answers for each problem. So we're going to go through a few of these. So starting with number 1. You're given a trinomial, your C value is 12. So off to the side I'm going to list out all of your factors of 12. What times what will give you 12? You can say it out loud. 4 times 3. What times 2? 6 times 2. We're missing 1. Times 12. So then of those sets of factors, if we were to add them or subtract them together, which ones would give us 7? 3 times 4. 4 times 3, whatever. If you want a way to organize all these numbers, you don't have to use this, but it might be helpful, especially when we get into our later factoring stuff. I'm going to draw in this big X. Whatever is multiplied goes in the top. Whatever is added or subtracted goes in the bottom. Then the 2 numbers you found go on the sides. The 2 numbers you found are going to be what you use for your answers. So kind of like difference of squares, you're going to start off with 2 factors, so your answer is going to be 2 sets of factors, where whatever the variable is going to come first in both. And then the 2 numbers you found is what you're going to put in both. Does not matter if you put plus 4 first or plus 3 first. Those would be our answers, our factors, x plus 4 and x plus 3. And we could distribute this back to see, does it give us this? If it does, then we know it's right. So we'll do that for this one, but not for every single one. So x times x would give us x squared. If you have room in your box, you can put it there. I just don't have room there. X times 3 would give us 3x. 4 times x would give us 4x. And 4 times 3 would give us 12. And if we combine our like terms, we'll get 7x. So that works. Questions on how this works before we do another? So think about number 2. Think about your factors of 20. What are they? 5 and 4. What and 2? 10 and 2. 21. We're looking for 2 numbers that multiply to be 20, but add to be 9. 5 and 4 would work. So as you are doing this, sometimes the first set of numbers you think of are the ones that work and you don't have to think about the others. Sometimes that's not the case, so it depends. So then our factors would be n plus 5, n plus 1. Any questions on that? Last one, factors of 1. 1 and 1. So if we're looking for two numbers that multiply to be 1, but add to be 2, there are only two that work, 1 and 1. So you can write it as y plus 1, or y plus 1 squared. And we'll do some more when we get back from lunch. Different types of examples. Did you need to sharpen that up? So the 3 examples we just did were all plus plus. Now we're going to do some different ones. So let's do 7. So with 7, because we have to multiply to get a negative 18 and add to get a positive 3, one of the numbers we find has to be negative. So let's think of the factors of 18 first. What are factors of 18? 9 and 2. Some others, and we can say these out loud. 6 and 3. 6 and 3. 1 and 8. So of these, one of the numbers would have to be negative in order to add to be 3. Add or subtract to be 3. Which ones would work? 6 and 3. Which one would be the negative one? So negative 6 plus 3 would give us a positive 3. The opposite. So positive 6 and negative 3. So then our factors would be n plus 6 and minus 3. Here's where the order matters a little bit. You can still put n minus 3 and plus 6, like that order doesn't matter, but I can't put n minus 6 and plus 3 because then it wouldn't work. Right? Questions on that one? Let's try 10. Think of your factors of 54. If you want to list them out, you can. And find two numbers that multiply to be negative 54, but add to be 3. Not sure about your factors, start at 1. Start dividing. 54 divided by 1, 54 divided by 2, by 3, by 4, keep going until you find some numbers that work. Matthew, laptop, shut up. 9 times 6, and one of them would have to be negative. Which one would be negative? Negative 6, positive 9, and then our two factors would be s minus 6 and s plus 9. Questions about that? Cameron? Yes. Because if I made it like this, if I added those two together, would that give me positive 3? So that order matters. Let's do one more of those and then we'll switch to something else. Let's do 13. Think of two numbers that multiply to be negative 30, where one is negative, that also add to be 7. you know your factors, that's great. But if not, use your calculator. Say that again. 3 and 10. Which is negative? Which one would be negative? So 3. So x minus 3, x plus 3. Right? So that's what happens when we have a plus minus. Now we're going to do the opposite and see what happens when we have a minus plus, but there aren't any on this page. There are some on the back. So if you look on the back of this same page, and things like 7, 8, 10, 14, those are all these types of examples. So if we're multiplying to get a positive number, so like in 7, multiplying to get a positive 8, how could we add or subtract to get a negative 6? So let's think about what would happen to get a positive 6 first. Cameron? 4 plus 2. How would we make it a negative 6? Cameron? So if they're both negative, then they multiply to be a positive and add to be a negative. So with these type of examples, you'll have to be thinking about that. So y minus 4, y minus 2. Questions on that one before we do a couple more? Let's try 11. 70 is a bigger number, so you may want to list off the factors or use your calculator. Start dividing by 1, by 2, by 3, keep going. Matthew, are you doing this on your calculator? X minus 7, x plus 10. As long as you are double checking to make sure the numbers you're multiplying do equal whatever, and the numbers you are adding or subtracting together do equal whatever the middle number is, then you're good. Alright, one more, and then we'll switch to the last type. So number 14. Think of two numbers that multiply to be 56, but add to be negative 15. What two numbers did we find? 8 and negative 7 work. B minus 8 and B minus 7. We're going to flip back to the front do a couple of those examples and then flip back to this page after that. And then 15 through 18 are the last type, where we have minus minus. So if this one is negative, one of the numbers have to be negative when we multiply. So find two numbers that multiply to be negative 63, where one of them is negative, and add or subtract to be negative 2. Yeah, that would work. B plus 7 and B minus 1. We'll do one more of these and then do our last thing with this type of factoring. So let's try 18. Find two numbers that multiply to be negative 72, where one of them is negative, that add or subtract to be negative 14. Find the two that work yet? Just taking 4, which one would be the negative? So x minus 18 and x plus 4. So as long as you're able to find the factors, look at the factors, add or subtract them together to find the middle, then you can do this. Right. Any questions on how we factor the basic trinomials or a equals 1 trinomials? We're going to add an extra step on the back of this page. We're going to do a couple of these examples where we now have to factor out a GCF and then do what we just did. So basically, GCF can be combined with all of the different types of factoring, as we saw last class. So for number 19, we have to look and see what do each of these have in common. Something we can divide each of them by. Now, as a hint, usually whatever the first number is will be what you can divide them all by. Remember that we're dividing each thing by 2. You don't have to write that part, but you can. But we do need the 2 in front of parentheses. I wrote that kind of low. What would be left when we divide 2 by everything? What would be left in this first term? K squared. And then the next one? Minus 4k, and the last one. So after you get that GCF taken care of, then you have to look and see can we factor it like we were just doing? Can we find two numbers that multiply to be negative 45 but add to be negative 4? Usually, the answer is always yes, and you have to figure out what those numbers are. Very rarely, the answer is no, and that would be it. Are there two numbers that multiply to be negative 45 and add to be negative 4? Just be. 5 and 9 are the answers, but you just switch them. So negative 9 and positive 5. So then we would leave the 2 out in front. Write your two factors next to it. K minus 9 and K plus 5. If you want to write it with double parentheses, so like here, you could do that. You don't have to do that. Questions on how we factored out that GCF and did the basic trinomials or trinomial equal or A equals 1? So then for 20, what do those have in common? Not a number this time. How X? Okay. Each have an X that you can divide out. Remember that when you're dividing your variables, you're subtracting the exponents. And these all have exponents of 1. So what would be left?
X squared.
Right? Then same process. Look for two numbers that multiply to be 48, negative 48, and add to be 2. So negative 8 and positive 6. So x minus 8, x plus 6. Questions on that one? Right, and then 21. What do those have in common? Remember, we're trying to get it back to A equals 1. Go ahead, Cameron. 4. So if we divided each by 4, what's left? Go ahead, Lily. Then we're looking for two factors that multiply to be 30, negative 30, but add to be negative 13. Be careful with this one. You may come up with numbers that are not the right ones. Sophia? Say that one more time. Yes. So that one works. Negative, except we'll be backwards. Negative 15 and positive 2. However, if you were thinking 3 and 10, that would not work. 3 negative, if you made one of them negative, it would give you negative 30, sure. But in order to get negative 13, they would both have to be negative. And if they're both negative, then 30 would be positive. So that part doesn't work. So be careful with those. There are some like that. They're They're to really trick you, but those would not work. Questions on that one? Once you are done writing, go on to the next page. This will help us with the last piece of factoring or factoring method we have to do. This can be done on its own / in the process of the last one. But on its own, with grouping, you can only do this when it has 4 terms. So what you're going to do is group these together, the first 2 and the last 2, so you can either use parentheses or just draw a line separating them. The sign of the third term goes with the second set of terms. Then we're going to look for the GCF on both sides, so separately. What do these 2 have in common? X squared, the variable, yes. I'm going to put that on the outside. I'm going to divide both of these by x squared. What would be left when we do that? For this one? So then that sign, plus or minus, whatever it is, you're going to bring that down. What do the second 2 have in common? Yes. We could divide both by 2. So we're going to put the 2 in front. What would be left if we divided those both by 2? X plus 7 again. Notice that the inside parentheses are the same. That's what you want. If that does not happen, you did something wrong, something's off. Those should always be the same. You could almost assume they're going to be the same, but don't at the same time actually do the work. Right? If these 2 things are the same, that becomes one of your factors. Only write it once. And then the things on the outside, the things we factored out, x squared plus 2, you're going to group those together in parentheses. And that would be your second set of, that would be your second factor, sorry. So those would be your answers. Then to check yourself, you could always distribute it back. X squared times x would give us x to the third. X squared times 7 would give us 7x squared. 2 times x would give us 2x. And 2 times 7 would give us 14, which is what the original was. Again, the distributing part is not a necessary thing, but if you want to check yourself, that's a good thing to have, good tool to use. What questions do we have about the process before we try a couple? So we're going to start with 1, and then you guys can look at any you want to do, see, or go over. So same process. Split it down the middle. What do those first 2 have in common? Three. And what else? Someone said x, but how many x's? 2. So if we divide both of those by 3x squared, what would be left? Bring down your negative. You don't have to draw in this arrow, I'm just showing where it came from. What can we divide out of the last 2? 2. But because we brought down that negative, we're going to be dividing by negative 2. So your signs are going to change. So then if we divide out negative 2, what's left? X plus 5. So then we can write our two answers. The x plus 5s are the same, so that's one of them. Again, the order doesn't matter whether I put this one first or the second one first. What would the other factor be? What are the things on the outsides that we factored out? Lily? So then those would be our two factors. What questions do we have so far? Look at the other examples. Find any you want to see, do, go over, have questions about. So let's do 6. There are also some on the back if you wanted to find one of those. So split it down the middle. What do those first two have in common? Alex? X squared. X squared. We can divide x squared out of both. What would be left? Go ahead, Alex. Y plus 3. Y plus 3. Bring down your negative. What do the second two have in common? Y and something else. We can divide them both by 7. So 7y. We divide them both by negative 7y. What would be left? Y plus 3. So then what would your final two answers be? What would your final two factors be? Go ahead, Lily. Just like that. Are there any others we want to see, do, go over, have questions about? Just be 10. So 10 is all variables, but it works just the same. Split it down the middle. What do the first two have in common? A squared. We divide out a squared to both of these with left. Just can say that louder. A plus B. Bring down the plus. What did the second two have in common? B. So if we divide B out of both, what's left? A plus B. And then what would our final answers be?
A squared plus B and
A squared plus B and A plus B. Any others we want to see, do, go over, have questions about? Matthew. 11. What were you going to say? Does it matter which concept comes first? Nope. I can put A plus B and then A squared plus B. Either or, doesn't matter. We could do 11. What do those first two have in common? 4RS, yes, all of the above. Divide that out of both pieces, what would be left? Matthew?
RS.
The first one would just be R. but minus 4, not 4. 2, there we go. Bring down the negative. What do the second two have in common? 3. Divide negative 3 to both. What's left? Would it still be plus if we're dividing by a negative? Minus 2. And then our two factors would be what? And I want you guys to have time to practice, work on Khan Academy, stuff like that. So for the remainder of class, you can be working on practice from the note, practice from the little pink book I gave you guys, or Khan Academy that was past due, do this week, do next week, work on as much as you can. Let me know if you have questions, work together, use